Okay, our next lesson, lesson number 2 of unit number 6. We'll be using the sum and difference formulas for the sine, cosine, and tangent functions. So, what do these look like? Well, sine of u plus v is equal to sine u cosine v plus cosine u sine v. Remember, we talked about this before, we often use u as a universal variable. So if I'm actually solving an equation, I'll often use x, or in the case of trigonometry, I'll often use theta. But when we have one of our equations that takes a variety of variables, we'll use u as the universal variable, and of course alphabetically v will be next. So if I was actually solving an algebra equation, I might use x and y as my two variables, or with trigonometry, I might use alpha and beta as my two angles. Sine of u minus v. Gotta do the minus first. Sine u cosine v minus cosine u sine v. Now we can get into cosine. Cosine of u plus v, cosine u cosine v minus sine u sine v. Of course, now we gotta do cosine of u minus v, which of course will be cosine u cosine v plus sine u sine v. Those four are actually quite easy to memorize. The ones that are a little bit more tricky, tangent. You'll notice in each case that you've got a tangent of u in the numerator and a tangent of u in the denominator, a tangent of v in the numerator, a tangent of v in the denominator. In the numerator, they're either being added or subtracted from each other. In the denominator, they actually get multiplied, but then they're either subtracted from 1 or added to 1. The reason why I think sine is so easy to remember is that sine keeps the sign, right? The sine function will keep the operation sign the same. So if it's sine of u plus v, notice there's addition in the middle. If it's sine of u minus v, notice there's subtraction in the middle. Right? So sine will keep the operation sign. Now the cosine function, well, cosine conjoins like functions. Right? So if I'm doing cosine of u plus v or cosine of u minus v, it keeps the cosines together, it keeps the sines together. So if you're going to work with the sine function, you'll keep the addition or subtraction, but it scrambles the functions. If you're working with cosine of u plus v or cosine of u minus v, it'll keep the functions together, but it'll scramble the addition and subtraction. Tangent is not quite so much a major focus. We might touch on it here and there, but sine and cosine will be where most of our study goes into. Okay, let's find the exact value. Let's look at cosine of 5 pi over 12. That's not a value I have memorized. It's not a value on my unit circle. The reason why it's not on the unit circle is I cannot get that off of a 30, 60, 90 triangle. I cannot get that off of a 45, 45, 90 triangle. Right? I've got my two special right triangles that allow me to do 30-degree angles, 60-degree angles, 45-degree angles. What can I do with 5 pi over 12? Well, I know 5 is 3 plus 2. So how about 3 pi over 12 plus 2 pi over 12? That adds up to 5 pi over 12. course, each of those fractions will reduce. So 5 pi over 12 is really pi over 4 plus pi over 6. Aha! Cosine of u plus v. Right? U in this case is going to be pi over 4. V in this case is pi over 6. Remember, cosine keeps the functions together. So it's going to be cosine u cosine v minus sine u sine v. Cosine of u is cosine pi over 4. Then we need cosine of v, so there's a pi over 6, minus sine u sine v. All right, it keeps the functions together. Of course, cosine of pi over 4, I know, is root 2 over 2. Cosine of pi over 6, of course, is root 3 over 2. Then I guess I probably need a subtraction symbol. Sine of pi over 4, root 2 over 2. Sine of pi over 6, 1/2. Of course, if I do my multiplying, root 2 times root 3 is root 6. 2 times 2 is 4. Root 2 times 1 is root 2. 2 times 2 is 4. Hey, how lucky can I get? There's a common denominator. So my numerator will be root 6 minus root 2. My denominator will be 4. So there is the exact value for cosine of 5 pi over 12. Square root of 6, subtract square root of 2, divided by 4. Now let's do something a little bit different. Instead of using the cosine function, we'll use the sine function. And since we just did an addition, let's do subtraction. What on earth can make a 17? Well, I'm thinking 20 minus 3 sounds good to me. Right, 20 pi over 12 minus 3 pi over 12 is 17 pi over 12. Now, do those fractions reduce into something useful? Well, 20 over 12 is 5 over 3. 3 over 12 is 1 over 4. Hey, 5 pi over 3, sure enough, that's on our unit circle. Pi over 4, that's on our unit circle. So we're actually looking at sine of 5 pi over 3, subtract pi over 4. Now, sine keeps the sign, so we're going to have subtraction, but the functions get scrambled. So this one will become sine u cosine v minus cosine u sine v. Right? Sine u cosine v minus cosine u sine v. Of course, every time I've got u, I'll insert 5 pi over 3. Every time I've got v, I insert pi over 4. Of course, 5 pi over 3. Sine is negative at this point. Cosine of pi over 4, that's just our root 2 over 2. Then there's that subtraction symbol. Cosine 5 pi over 3 is positive 1/2. Right, because 5 pi over 3 is in quadrant number 4. Well, sine is negative. Cosine is actually positive there. Right, for quadrant number 4, you go to the right and then you go down. So when we go to the right, cosine is positive. When we go down, sine is negative. Finally, sine of pi over 4, that's in quadrant 1, so just root 2 over 2. Let's see here, root 3 times root 2 is root 6. But of course, there was a negative with that root 3. 2 times 2 is 4. Then I have my subtraction symbol. 1 times root 2 is root 2. And of course, 2 times 2 is 4. Common denominator, so we can combine like terms. I've got a negative root 6, and then I've got subtract root 2, so that's like a negative root 2. Whole thing over 4. We could leave the answer like that, but when both parts of the numerator, both terms are negative, most of the time mathematicians will just factor the negative out and put it in front. So you've got negative, and then the fraction is root 6 plus root 2 over 4. Right, if only one of the terms had a negative symbol, then we would have just left it. But since they both had that negative symbol, we just factored out front. Of course, we've been doing other things besides finding exact values of trigonometry. We've been solving equations. Limited to just one time around the unit circle, otherwise we have an infinite number of solutions. So what would happen if we took sine of theta plus pi over 3, added that to sine of theta minus pi over 3, and let's say it's equal to 1. Well, again, sine of u plus v, sine u cosine v plus cosine u sine v. And of course, sine of u minus v, sine u cosine v minus cosine u sine v. And of course, I still have my equal 1. Hey, something's matching. A positive cosine theta sine of pi over 3, a negative cosine theta sine pi over 3. Those cancel, they add up to 0. We can get rid of those. Looking a lot simpler already. Of course, you know what cosine of pi over 3 is. Cosine of pi over 3 is just 1/2. Of course, I have half of a sine theta plus another half of a sine theta. I just have 1 sine of theta. Of course, I'm not going to write 1 sine theta, right? Because 1 times sine of theta is just sine of theta. So where are we? If the sine of theta is 1, well, that's the top of the unit circle. We're at pi over 2 radians. A lot of work, just one solution. Kind of unusual to come up with just one solution usually. Oh, this looks fun. Sine and cosine mixed together. Okay, so again, for sine, I gotta remember, for u plus v, sine u cosine v plus cosine u sine v. But of course, I've got to put all that in parentheses because that whole term was being multiplied by 4. Of course, cosine of 7 pi over 6, that's negative root 3 over 2, right? We're in quadrant number 3. Both sine and cosine are negative in quadrant 3. Right? Because 7 pi over 6 is just past pi. Sine of 7 pi over 6 is negative 1/2. So I can use the distributive property. 4 times negative root 3 over 2 becomes negative 2 root 3. 4 times negative 1/2 becomes negative 2. Oh, looky, looky. Negative 2 cosine theta, positive 2 cosine theta, those will cancel out. Subtract 3 from each side. Divide each side by negative 2 root 3. And if I can just simplify that fraction, I'll be able to proceed. Well, I know negative divided by negative will come out as positive, so I can get rid of the negative symbols. And if you don't see how this turns into root 3 over 2, let's take a look step by step. I'm going to multiply it by the number 1. I disguise the number 1 as root 3 over root 3. I now have a numerator of 3 root 3. Denominator 2 times the square root of 9, because root 3 times root 3 makes root 9. Of course, square root of 9 is plain old 3. I can cancel my 3's. Sure enough, root 3 over 2. So where am I if sine is positive root 3 over 2? Well, I must be at pi over 3 or 2 pi over 3. Because I'm at a 60-degree angle. And sine is positive in quadrants 1 and 2. So I'm either at the 60-degree angle in quadrant 1, which is pi over 3, or I'm at the 60-degree angle in quadrant number 2, which is 2 pi over 3. Hey, this is what else we like to do. We like to verify identities. Of course, what is always my first step? Well, my first step is always write down the left-hand side. So I'm going to start with sine of theta plus pi over 2. Of course, this will expand to become sine u cosine v plus cosine u sine v. All right, sine u cosine v plus cosine u sine v. All right, the sine function will keep the addition sign, but the functions get scrambled. So I've got sine of theta times cosine of pi over 2 plus cosine theta times sine of pi over 2. Of course, cosine of pi over 2, well, we're not going left or right on the unit circle, right? That's the top of the unit circle. Cosine of pi over 2 is 0. Sine of pi over 2, that's 1. I've got 0 times sine of theta plus 1 times cosine theta. That's just cosine of theta. We need one a little bit more challenging than that. Now again, if I'm doing algebra, I would usually use x and y for my variables. When I'm doing trigonometry, if I just have the one variable, I'll usually just use theta for my angle. But when we use more than one, I often will use alpha and beta instead of x and y. So let's start with the left-hand side. And of course, cosine will keep the functions together. So cosine alpha plus beta becomes cosine alpha cosine beta minus sine alpha sine beta. Cosine of alpha minus beta becomes cosine alpha cosine beta plus sine alpha sine beta. Right? It keeps the functions together, but the addition and the subtraction get scrambled up. Well, oh, I see what we can do. Look at what we're looking at. We need to do some multiplication. There are 2 terms inside each parenthesis. All right. First, outer, inner, last. Right, these basic algebra skills just keep coming back. And it looks like O and I will combine and become 0. Right, because we've got a positive cosine alpha, cosine beta, sine alpha, sine beta. And we have a negative cosine alpha, cosine beta, sine alpha, sine beta. Those cancel out. And we're left with exactly what we were looking for. Again, another worksheet today, 6.2.